Okay, good morning. Good morning, everyone. The interim exam this month. Okay, somebody has asked. So, right. So, our end-term examinations will be next month after your the remedial classes. That is till July 3rd. You have remedial classes. After that, the schedule will be given. The EG examination will be conducted along with your theory examination. So this month you have only workshop and your physics lab. You will be having a end-term lab examination. Okay. So I hope I have cleared that doubt. So let us continue with this. So yesterday we started with the introduction to projection of points. So and then the projection of straight line also we have discussed. A straight line. So it's a one-dimensional object. So it has got only the length, the thickness we are neglecting. So that's what yesterday we have discussed. So we have discussed few more things in straight line. True length is nothing but it is the actual length of the line. So when you will get the true length, whenever a line is parallel to any one of the plane, the corresponding view you will going to get the true length. For example, if it is parallel to HP, you will get the true length in the top view. Parallel to VP, you will get true length in the front view. Similarly, the parent length also we have discussed. The parent length in the sense always it is less than the true length. When you will get the apparent length, when a line is inclined to any one of the plane, then you will get the corresponding view as the apparent length. For example, line is inclined to HP, then the top view will going to get apparent the view or apparent length. Whenever a line is inclined to VP, then the corresponding view in the sense the front view will going to get apparent length. And we discussed the true inclination as well as the apparent inclinations. Okay, the inclination formed by the true length of the line is called true inclination. If it is with respect to HP, it is theta. If it is with respect to VP, it is phi. Similarly, apparent inclination, the inclination formed by the apparent length of the line. So it might be a front view or top view. So with respect to HP, it is called alpha, and with respect to VP, it is called beta. That's all. So these things we have discussed, and the position of the straight line, the three cases we have discussed yesterday: parallel to both the plane, parallel to one plane, and perpendicular to other plane we discussed, and inclined to one plane and parallel to other plane we have discussed. Today we will discuss inclined to both the planes. So this is the position of the line where it is inclined to both the plane. So neither it is parallel to HP nor it is parallel to VP. That means both front view and top view will going to get the apparent shape only, because it is not parallel to any one of the plane. This is the case what we will going to discuss. Before starting the exercise, let me tell you. So this is the position. So in the straight line, so one end is always fixed, other end we can able to rotate it. This is what you have learned. Okay, so that means in inclined to both the planes, so it is not parallel to HP, neither parallel to HP as well as nor parallel to VP. Then how to get the true length? Because true length of the line, most of the cases in the exercises it is given are apparent. In some cases we need to find out either the true length or the apparent length, or true inclination or apparent inclination. So this is the actual position of your line. So and always you have to remember that any one of the end of your line is always fixed, that we cannot rotate it. The other end of the line can be rotated, so that to get the true length of the line. For example, this is the position where it is inclined to HP some angle as well as inclined to VP also some angle. So it's inclined to both the plane example. So with this, only the top view and front view I can draw. I cannot get the true length of the line. So when you will get the true length of the line, when the line is parallel to any one of the plane, that time only you can get the true length of the line. Now to do that, a small exercise you have to do it. Okay. So as I told, this is inclined to both the planes, the position. So it is inclined to both HP as well as inclined to VP. And here any one end of your line has to be fixed, that we cannot disturb. Other end can be rotated for my convenience. How to do this to get the true length? So let me fix this the lower end of the line, and upper end I'll be rotating it. See, so it is like this. I'll be rotating it first till it is making parallel to VP. So the line it was, this was the position of the line inclined to both the position. So I'm tilting it till it is making parallel to VP. Now it is parallel to vertical plane. Why I made it parallel? If I make it parallel with respect to VP, I can get the true length in the front view. So this is what I have done. See, I have rotated it. While rotating it, the locus of this point, this other point, does not changes. Only the position of that in that line it changes, but the locus of that line doesn't change. That is what the, then after drawing a true length, so in the front view, if you see this line, because it is parallel to VP, front view will go to get the true length. Then after that, you bring it back to its original position. Then how to draw the true length in the top view? Do the same thing. Lower end you fix it, upper end you can rotate it like this till it is making parallel to HP also, like this. If you see from the top, so you can get the true length in the top view. After rotating it, so making it parallel after getting the true length of the line, once again you bring it back to its original position. Now, while tilting it here also, the locus of this line doesn't change. This particular point doesn't change. Only the position changes in the same plane. So this is what the exercise that we have to do. That's all. With this small the basics, let us start the examples, different examples in the production of straight lines. The first exercise. So before starting the exercise, in straight line, what you have to do is, first you read the question once, twice or thrice, and right side, so put a box, and in that what all the data he has given, mark it everything. List all the data whatever you have given and write the data, and then what are the things that you need to find out at the end, that also you list it out and put a question mark. So at the end, what are the things that you have to find out, you have to write the answer in this case. This is what the practice that you have to do it. So let us start the first the example. So he says a line AB 80 millimeter long has its end A 20 millimeter above HP and 30 millimeter in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Draw the projections of the line and find the apparent lengths and apparent inclinations. So after this, so as I told, in straight line onwards, so we discuss only the first quadrant examples. So directly you can draw a XY line and VP above XY line and HP below XY you can write directly, because it's the first quadrant the problem. So front view will going to get above XY line as well as the top view will going to get below XY line. So after reading it, so once again let me read once again and list out all the data. A line AB 80 millimeter long is says, that means this is the actual length of the line. Got it? That means true length is equal to 80 millimeter. You can write right side. Next, as it end A 20 millimeter above HP and 30 millimeter in front of this information. This is the lower end A. It is 20 millimeter above HP and the 30 millimeter in front of VP. This information with respect to lower end he has given. That is a fixed end. That we cannot change it. That is what he has given. Next, it is inclined at 30 degree to HP and 45 degree to VP. This is a true inclination of your line. That is theta. That is with respect to HP, it is theta. Theta is equal to 30 degree. You can make a note. And 5. The inclination with respect to VP. It is 45 degree. You can write. These are all the three data which he has given. True length is given. The true inclination with respect to HP, theta is given. True inclination with respect to VP, phi is given. And the lower end distance with respect to HP and VP, it is given 20 millimeter above HP and 30 millimeter in front of VP. And we need to find out at the end. We have to draw the projections first. We have to complete the projection. We need to find out the apparent lengths. Apparent lengths in the sense, the front view and top view length you have to find out at the end. And then apparent inclination. What is apparent inclinations? The apparent inclination is nothing but your alpha and beta you need to find out. Okay. Let us start with this data, whatever we have listed up. First I have drawn the XY line, I have written the VP as well as HP also. Now, so he says the end A is 20 millimeter above HP. Above HP means above XY line. You take 20 millimeter above XY line, draw one horizontal projector line, and anyway, by keeping 5 millimeter distance from the dimension line, you mark one point and call that as the A dash point, because that is a end A. So I am writing it in front view. That's why I have taken it as the A dash, and draw on this the horizontal projector line, whatever you are drawing it, you call that as the locus of A dash. Okay. Next, coming to the other one, and 30 millimeter in front of VP, he says. In front of VP means it should come below XY line. You take 30 millimeter below XY line. You take 30 millimeter below XY line and draw one horizontal projector line. Draw one horizontal projector line and call this as the locus of A in the top view. And already you have marked the A dash. You draw the vertical projector downwards like this. Wherever it meets the locus of A, that is 30 millimeter line. So you mark that point and call that as the A. So that means the end A, both in top view and front view, we have identified and we have fixed. So this is the first step what you have to do it as per the information which is given. Now the second, the sentence he says the true length of the line, we know it is 80 millimeter, and he has given the true inclination theta 30 degree and true inclination phi 45 degree as given. So after that, what you have to do, you consider from A dash, what you have to do, you draw a 30 degree line. That's what I told. Always HP inclination you can see in the front view, VP inclination you can see in the top view. This also a small clue you can remember it. So the theta, so you take theta 30 degree, from already A dash we have marked, you draw a 30 degree line, 30 degree line, and this is a true inclination. On true inclination, true length of the line should come, right? What is the true length of the line? True length of the line is 80 millimeter. So from A dash is the center, you take 80 millimeters as the radius and cut this 30 millimeter, the 30 degree line. Wherever it cuts, okay, wherever it cuts, from that point you draw the horizontal projector line and you call this as the locus of B dash. Locus of B, and this is not the your front view point, it's a true length point. That's why I won't call it as B dash. I'll give some other name. I'll call it as B1 dash. So A dash and B1 dash, you make it medium thick. Okay, it's a true length of the your line in the front view. So this completes your true length diagram in the front view. Similarly, same thing you have to do it to get the true length diagram in the top view also. That means here you can see, you take this, the A as the center, you draw the 45 degree line, that is with respect to VP 45 degree as given. You draw a 45 degree line from A. After drawing this 45 degree line, what is the true length? True length, whether it is if you draw it in the front view or you draw it in the top view, it remains same. Okay, it's the actual length of the line. From this A as the center, 80 millimeter as the radius, you cut this 45 degree line. Once you cut this 45 degree line, wherever it cuts, from that point you draw the horizontal projector line and call that as the locus of B. And here this is also a true length point, so it is not the B. I cannot give B, so some other name I'll give. There I have given B1 dash, here I can give B2 because it's a top view, I cannot use dash. So B2 I have taken. So this is the second step. So till here, what are all the data he has given, I have used all the data. I have taken the point A, the distance with respect to HP and VP. I have identified the position of your point A in the front view as well as point A in the top view. Made use of the true length diagram, that is true length of the line 80 millimeter I have used, and the theta and phi I have used, and I have completed the true length the diagrams. So till here, what are all the data which is given, I have used it. Now I have to complete the projection, okay, with the procedure whatever. So I'll give you now. So now after this, what you have to do, so always you remember, so this exercise whatever we have done, see this is the incline to both the link. So we made it parallel to HP to get the true line diagram in HP, and then so this whatever the arc I am getting it while rotating it, okay, so this is the locus locus doesn't change, and that's why I have given the locus of A dash, B dash, and A and B. Once again, I'm bringing back. Similarly, I'm making it parallel to a VP also, so that I can draw the true length diagram in the front view. So I'm doing it. That means, so always you remember from the true length, if you want to draw the apparent length, always first you draw the vertical projector and then draw the arc. That is what. See here. So this is the true length diagram, right? So here, like this, you are tilting it. So that means what? So B1 I'll consider, which is the true length diagram. A dash and B1 dash is the true length in the front view. From B1 dash, you draw a vertical projector. You draw a vertical projector from the true length diagram, that is B1 dash, till it meets the locus of A in the top view. Once it comes to the top view, the B1 dash will become B1. You call this as the B1. Now what you have to do? The A as the center, B1 as the radius. I'll repeat it. A as the center, B1 as the radius. Draw an arc. Draw an arc in this direction, the arm arc, which is shows the direction, till it cuts the locus of B in the top view. Once it cuts this, now you call this as the actual point B. So this is your top view point. Now after getting this point B, you can join this AB with a thick line. So this itself is the top view. The top view is completed. Similarly, how to get the front view? To get the front view, I need to start from the true length diagram in the top view. So how to do that? So which is your true length diagram in the top view? AB2 is the true length diagram in the top view. From B2, whatever you have done previously, the same thing you have to do it here. So from B2, you draw a vertical projector till it meets the locus of A in the front view. So at this point, you call it as a B2 dash because it's a front view. Now A dash as the center, B2 dash as the radius. So you cut an arc like this till it meets the locus of B dash in the front view. Wherever it cuts, you call that as the B dash point. This is the front view point. Now you can join A dash and B dash with a thick line. So this is your apparent length, that is front view, and this AB is the apparent length. So that is your top view. And how to make sure that whether you have completed the projection perfectly correctly or not. So after doing it, you can see B and B dash should come on the same line. You can draw a vertical line from B to B dash. So it should come on the same line, same vertical line. If we here and there, if you are getting it, means somewhere else you have made a mistake. So this cross check at the end of the drawing, you have to do it. Once you complete the entire projection, what are the things that you need to find out? You need to find out the apparent length in the sense the front view and top view length. Which is the front view length? A dash and B dash is your front view. You measure this distance with the help of your scale. So you write that answer A dash B dash, that is front view length. It is coming around 56.57 millimeter. Similarly, the one more apparent length, that is top view length, AB is you are getting 69.28. That your answer you have to write. And also apparent inclinations also you have to measure with the help of your protractor. See, from here to here you have to measure the angle. It is coming 45 degree, and from top view to your line horizontal, the inclination, it is coming 55. So like this you have to measure at the end and you have to write all the answer. So the same procedure we have to use in the entire straight line, the examples. So this is how we have to complete the project. This is the first example that we have discussed. Next, second one. So let me take other example. So here in this case, just I'll read out. The top view of a line 75 millimeter long measures 50 millimeter. The end P is 30 millimeter in front of VP and 15 millimeter above HP. The end Q is 15 millimeter in front of VP and above HP. Draw the projection of the line and find its true inclinations with HP and VP. So that's what I told here. Some data are given, some data we have to find out. But what are the data he has given in the example of the question? So it is possible to complete the projection. So once again, let me start. What are the data that you have to list it out? I will tell you. The top view of a line 75 millimeter long measures 50 millimeter. So how we will collect the data? So he said the top view of a line 75 millimeter long measures 50 millimeter. That means the true length. Okay, the true length of the line is 75 millimeter. Okay, which measures 50 millimeter in the top view. That means true length is 75 millimeter. You can write, and top view length, that is apparent length. Top view length is 50 millimeter. That you have to write it. Next, the end P is 30 millimeter in front of DP and 15 millimeter above HP. That means first the one end of the line is P. He has given it is 15 millimeter above HP. You take 15 millimeter above XY line, draw an horizontal projector line, call that as the locus of P dash, and locate one point on that and call that as the P dash. Similarly, it is 30 millimeter in front of VP. In front of VP means it should come below XY line. Take 30 millimeter below XY line, draw one more horizontal projector line. Call this as the locus of P in the top view. Now, the same point you can already P dash you have taken the same point. You draw a vertical projector line like this down, and then wherever it cuts this locus of P in the top view, you call this as the P. So this is the point P in the top view, correct? And after this, one more data which we have to use, which is that the end Q is 15 millimeter in front of VP. You take once again 15 mm in front of VP means below XY line. You take below XY line 15 millimeter, draw one more horizontal projector line. One more horizontal projector line. Call that as the locus of Q. Call that as the locus of Q. That means, so after drawing this locus of Q, I need to get my, the P already I have written in the top view, Q and Q1 or Q2, whatever it is, I should get it on the same horizontal line. So I have taken this 15 millimeter below XY line, I have drawn the locus of Q in the top view. So till here he has given the data, and he says above HP. We don't know so much it is above HP, the point Q. That we need to find out. So after this, after drawing three locus, so let me take this true length. What is the true length he has given? 75 millimeter. So from P as the center and 75 millimeter as the radius, because the locus of Q we know. That's why I'll cut this locus of Q 75 millimeter, and I'll call it as the Q2 or Q1, whichever the name you want, you can call it. Join this P and Q1. So this is your the true length diagram in the top view. Similarly, the locus of the Q you know in the top view. The top view length is also given how much it is. The top view length is 50 millimeter. You take 50 millimeter as the radius and P as the center. You cut the same locus of Q here. And after cutting this, you call that as the Q. This is the top view point Q. Now you join this P and Q with the thick line. So this completes your the top view as well as the true length diagram in the top view. So till here, what all the data he has given, so I have used it, and I came till here. So now, so the rest of the things I need to complete the entire projection, and I need to find out what are all the other things which is asked in the question. So till here all of you understood. Now what I will do, I know the top view is completed and the true length diagram in the top view is also completed, correct? So now what I will do, from Q I will draw a vertical projector upwards like this, some length. I'll draw a, because Q is there means Q dash also should come on the same line, okay? Because P and P dash is coming in the same line means Q dash also, the other end of your the front view point also should come on the same point. So that's why I'll draw a vertical projector from Q some height like this, okay? After this, I don't know, anywhere on this particular line only I should get my Q dash. After this, I know the true length diagram in the top view. In the previous example also we have discussed, from the true length diagram I can get the apparent length, correct? So it means PQ2 I will consider. So this is the center. So this Q2, from here I will draw a vertical projector till it meets the locus of P dash, and I'll call this as the Q2 dash. Okay. Now what I will do, P as the center, P dash as the center, Q2 dash as the radius. From here I'll cut an arc. I'll cut an arc wherever this particular arc cuts this vertical projector of your Q. This intersection you call it as the Q dash. That itself is your front view point Q dash. Once you get the Q dash, you draw a line between Q dash and P dash. This itself is your front view. This itself is your front view. Once you get this Q dash point, you draw a locus line, the horizontal projector line. That is your locus of Q dash. That's all. So after this, the true line diagram I should draw in the front view also. How to do it? So till here, I hope all of you understood. Next step after completion till here. So what we need to do it? So either, so you know the true length distance, you know how much it is, 75 millimeter. From P dash as the center, 75 millimeter, you cut an arc, the locus Q dash, and I can mark that as the Q and dash, I can join it. So this is a shortcut method. Okay. So the true length, because it doesn't changes in top view or front view, it remains same. You can join P dash and Q and dash with a medium thick line. You can complete the projection. Or else, in general, how to get it means from the true length we can get the apparent length. Correct. Similarly, vice versa. If you know the apparent length, I can get the true length also. So entirely the procedure you have to do it in the reverse way. So how to do it? From the true length to apparent length, how we are doing it? First you are drawing the vertical projector, then you are cutting an arc. From the apparent length to true length, what you have to do? First you have to cut the arc, and then you have to draw the vertical. That's what you have to do it. So you know the apparent length, that is top view PQ, P as the center, Q as the radius, you cut an arc till it cuts here. So you call this as the Q1. Now from the Q1, you draw a vertical projector. Wherever it cuts the locus of Q dash, you call that as the Q1 dash and join this P dash and Q dash and measure that at the end. So it has to come 75 millimeter only. Okay, either the shortcut method also I have told. So directly you know the locus also, you know the true length also you can take directly from P dash and you can cut 75 millimeter. But with this method also you complete it and measure it exactly 75% you should get. So this complete the entire projection. What are the things you need to find out at the end? So he has asked the true inclinations you have to find out. So which is the true length? P dash and Q dash. This inclination with respect to horizontal line you find out, that is theta is 45, and which is the true line diagram in the top view, PQ2. So this inclination with respect to your horizontal line, you measure it and then you mark that is 5. So these are all the answers at the end you need to find out. Okay, like this is one variety of the problem where some data are given and few data you have to find out. So this is how you have to complete the example. Next, one more different the type of the example we will discuss. So here what it is given, the distance between the end projectors through the end points of a line AB is 60 millimeter. The end A is 10 millimeter above HP and 15 millimeter in front of BP. Full stop. The end B is 35 millimeter in front of BP. The line AB appears 70 millimeter long in the front view. Complete the projections. Find the true length of the line and true inclinations with respect to HP and BP. So here, so let me start from the beginning. The distance between the end projectors through the end points of A and B is 60 millimeter. He has given this is one data. Yes, that means what exactly this in the sense that end projector, this is one end, this is inclined to both the position, example. So this is end A and this is end B. The distance between end projector through the end point of a line is 60 millimeter. That means this perpendicular distance. So this perpendicular distance between the point A and B is given. So from here to here, this perpendicular distance is given here. So that is what the data he has given. So after that, so what it is given, it is 60 millimeter. I'll take that. The end A is 10 millimeter above HP and 15 millimeter in front of BP. So I'll draw a XY line. I'll take HP and BP. End A is 10 millimeter above HP. I'll take 10 millimeter above XY line, draw an horizontal projector line, and call it as a locus of A dash. and locate one point and call it as A dash because it's a front view point. Similarly, it is 15 millimeter in front of BP. You take 15 millimeter below XY line and draw an horizontal projector line and call that as the locus of A in the top view. Already point A dash you have marked it. Draw a vertical projector from there wherever it cuts 15 millimeter. So this is your the point A. So both point A and A dash we have fixed. Okay. So after this, what he has given? The end B is 35 millimeter in front of VP. So in front of VP means below XY line. You take 35 millimeter below XY line and draw one more horizontal projector line. Call it as the locus of D. 10 millimeter, what is that? 35 millimeter in front of VP has given. Done. The line appears 70 millimeter long in the front view also, he says. Okay. After getting this locus of B here, so draw the horizontal projector line and then so end projector distance he has given, which is always measured perpendicular to it. So if the line is like this perpendicular distance is given over there. That means already A, look, it's a point A and A dash you have fixed up. So from here you take 60 millimeter distance. From here you take 60 millimeter distance and draw one vertical line. Draw one vertical projector line. Okay. So after drawing this vertical projector line, so that is 60 millimeter line. This is end projector distance. That means on this particular line only my B and B dash should come. Okay. So wherever this vertical line cuts this locus of B in the top view, okay, it is cutting it. So this point itself is my point B, that is top view. After identifying this point, you can join this AB with a thick line. So this is your top view. So till here I can complete. Okay, as per the information which he has given. And one more information he says after this. So I have joined it AB. So this is your top view. So after this, one more information he says, that is the front view is so front view is 70 millimeter. He says, correct. So from A dash as the center, you take front view length 70 millimeter. From A dash as the center, you cut this vertical line, that is 60 millimeter line which you have taken. You cut this 70 millimeter and call this as the B dash point. This is front view length. And draw a horizontal projector line and call this as the locus of B dash. And you make this line also a thick line, that is A dash and B dash. So this completes both my front view and top view. So what all the available data I have completed till here. Now I need to complete the projection. So complete the projection in the sense the true line diagram also I should draw from this. So how to do it? From the true line diagram we need to, from the true line diagram we need to okay, so in between it got stuck. So till here all of you are completed, both the top view as well as front view are completed. So now from here, as we have discussed in the previous example, from the apparent length, that is front view and top view, to get the true line diagram, so we need to draw the arc first and then draw the vertical projector. That means first what you have to do, A dash as the center, let me take it in here, A dash as the center, B dash as the radius, that is this is your front view length. You draw an arc first. Draw an arc first and call this as the B2 dash, and from B2 dash you draw a vertical projector. So wherever it cuts this locus of B in the top view, you join it. So this is your, the AB2 is your true line diagram. Okay, it should be a medium thick. Now the shortcut method, what I have told, AB2, because the true length remains same. You can take this distance from A dash, you can cut so on the same locus of B. So you're going to get B1 dash. You're going to get B1 dash. Or else, how to do it from the top view? From AB has the radius, A has the center, you cut an arc like this. Okay, call it as the B1. Now you draw the vertical projector till it meets the locus of B dash. You call this as the B1 dash and join it. So at the end you can measure both the A dash and B1 dash and AB2. It has to match. That is the true length diagram. So this is how you can able to complete the entire projection. What he has asked in the question. So we need to find out the true length. You measure any one of the true length either in the top view or front view and measure it. And true inclinations, that is theta and whatever it is asked, you find out at the end. So that is the answers. So one more variety we'll discuss. Fourth one end of a line is 30 millimeter in front of VP and 30 millimeter above HP. The line is inclined at 40 degree to HP and its top view measuring 60 millimeter is inclined at 50 degree to XY line. Draw the projections of the line and determine true length and inclination with HP. So let me read once again. One end of a line is 30 millimeter in front of VP. He has asked. One end of the line is 30 millimeter in front of VP and 30 millimeter above HP. Okay, so you draw XY line, fix HP and VP, take 30 millimeter above XY line and 30 millimeter below XY line, draw the horizontal projectors, locate any one point, in front you call that as the A dash, and then draw a vertical projector from there, you call the corresponding point as the A. Okay, so after this, the line is inclined at 40 degree to HP. So the true length is not given in this, but the true inclination with respect to HP is given. What is that? Theta he has given. Okay, so theta he has given from the question. So from A dash, the theta always we can see in front view, that is HP inclination. From A dash as the center, you draw 40 degree line and leave it as it is. Okay, 40 degree line. Theta you can draw. And its top view measuring 60 millimeter. That means top view length he has given. So data, theta he has given 40 degree to HP. Top view length he has given 60 millimeter. And he says the top view is inclined at 50 degree to XY line. Okay, the top view inclination, that is top view inclination is nothing but it is beta. Correct? This apparent inclination, whatever he has given, it is the apparent inclination. Okay, so apparent inclination, that is beta he has given. So what I should do after this? So I will take this as the center. The beta I can see only in the top view apparent inclination. I'll draw a 50 degree line. I'll draw a 50 degree line, and then I'll take, because the apparent inclination should come on the apparent length, correct? So the top view length, how much it is given? 60 millimeter. And this 50 degree, as the center, you cut this 60 millimeter and call it as the B, point B, and call this as the point B. Join this AB, so this is the top view. And once you get the B, you draw the horizontal projector line and call it as the locus of B. Okay, so after this, so one more data he has given, that's all. Okay, with this somehow I need to complete the projection. So just now in the previous example also we have discussed, from the apparent length we can get the true length, correct? So this AB is the top view apparent length. A as the center, B as the radius, you cut an arc. A as the center, B as the radius, cut an arc like this till it meets the locus of A and call this as the B1. Okay, after getting B1, you draw a vertical projector line. You draw a vertical projector line. Wherever this vertical projector line meets this 40 degree line, because 40 degree is the true inclination, that is theta. Wherever this vertical projector meets this 40 degree line, so you call that as the B1 dash. So join this A dash and B1 dash with a medium thick line. This itself is the true length diagram in the front view. From B1 dash, you can draw a horizontal projector line and call it as the locus of B dash. So till here you can complete it. After this, the true line diagram in the top view as well as the front view also I need to complete it. Okay. So after this, how to draw a front view? It's very easy because already B is there. B dash should come on the same line. Correct. Locus of B also we know about it. So from B you draw a vertical projector, and wherever it cuts the locus of B dash, you call that as the B dash. So B dash, that itself is your the front view point. So you join this A dash and B dash with a thick line. So this itself is your the front view, that is apparent length in the front view. How to get the true line diagram in the top view? Either already the true line diagram is here, A dash and B1 dash. You can take this, the shortcut method I am telling you. A as the center, you can cut this locus of B. You can join that and you can get it. So what is the actual method? So to get the true length in the top view, I should get the apart from the apparent length I should start, that is the front view. How to draw it? From A dash as the center, B dash as the radius. This is the apparent length. You draw an arc like this till it meets the locus of A dash. Then call this as the B dash. Now B dash as the point, you draw the vertical projector. Wherever this vertical projector meets this locus of B, call that as the B2 and join AB2. So this is your true line diagram in the top. Almost the correction is completed. What are the things he has asked? You measure it and write the answer. The true length he has asked, that is 78.32. It is coming. The true inclination with respect to VP it is asked, that is 536 degree. So like this, in this even n number of exercise also, if I solve the same procedure you have to follow. So one of the other data is given, you make use of that data. So complete the projection, and at the end we have to find out the answers. So one more example is there. One more the typical example I'll take, so that 5 examples we are discussing. So the rest of the things you can practice by yourself. So next one, what it is given? A line PQ measures 80 millimeter in length. A line PQ measures 80 millimeter in length. A line PQ measures 80 millimeter in length. This is true length he has given. The point P is above HP and in front of VP by 20 and 30 millimeter respectively. The distance between the end projectors is 50 millimeter. The distance between end projector is 50 millimeter. And then the line is inclined to VP by 30 degree. The line is inclined to VP by 30 degree. Draw the projections of the line and find its true inclination with HP as asked. Okay, the line is inclined to VP by 30 degree means phi is given. The true length is given, phi is given, and rest of the things we need to find out. Let me start. So draw XY line, fix HP and VP above and below XY line, and the point P is given 20 millimeter above and 30 millimeter below. You take 20 millimeter above XY line, draw horizontal projector line, and call that as the locus of P dash. Locate any point on that and call that as the P dash. Similarly, 30 millimeter in front of VP, you take 30 millimeter below XY line, draw an horizontal projector line, call it as the locus of P, and from P dash already you have fixed that point, you draw a vertical projector. Wherever it cuts the locus of P, the top you call that as the P. P and P dash you have fixed it. Okay. After this, he has given the phi has given the inclination with respect to VP has given. So from P, you take 30 degree and draw a 30 degree line. The true length is given. The true length should come on the true length, true inclination only. The true length is 80 millimeter. P as the center. So you cut this 80 millimeter 30 degree line. So wherever it cuts, you call that as the Q. That is true length. The diagram is completed. You join this with the medium thick line PQ to draw a horizontal projector line from this point. You call that as the locus of Q. Okay. Till here, so almost all the data. So he has given one more data. What is that? The distance between the end projector is 50 millimeter. He has asked. So that is distance between end projector is nothing but this distance. Okay, so what is this distance? So from P dash or P, you take horizontal distance 50 millimeter. This is the end projector distance. You draw a vertical line like this. Draw a vertical projector line from P or P dash. So wherever this vertical projector line cuts this locus of Q, you mark this as the Q itself and join this with a thick line PQ. So this is top view. Okay, this is top view. And how to get the front view? So we know the true length diagram here. From Q2 you draw a vertical projector line from here till it cuts the locus of P dash and call this as the Q2 dash. Now P dash as the center, Q2 dash as the radius, you cut an arc. Wherever this arc cuts the 50 millimeter, the end projector line, and that point you call it as the Q dash. Join this P dash and Q dash is a thick line. This is your front view. Okay. Now we can draw the horizontal projector line and call that as the locus of Q dash. So this completes the front view diagram also. How to draw the true line diagram in the front view? So you know the top view. So 80 millimeter already we know that from P dash directly I can cut this locus of Q dash. I'll get the true line diagram. Okay. How to get it through the procedure? PQ is the apparent line, that is top view. P as the center, Q as the radius, you cut an arc till it cuts the locus of P. Call this as the Q1. Now you draw a vertical projector from here. Wherever it cuts this locus of Q dash in the front view, you call that as the Q1 dash and join this P dash and Q1 dash. This is the true line diagram in the front view. At the end, you measure this P dash and Q1 dash. So definitely it has to be the true length, that is 80 millimeter, whatever he has given. So this complete the projection. What are the things that you need to find out at the end? So according to the question, whatever he has given, you need to measure it and you have to write the answer. That's all. So this is how the complete the details have given step by step procedure. How to read the question and how to note down all the data. That's what always you make a practice. First you read the question carefully and what all the data he has given, you mark it one by one. You mark it one by one, and what are the things that you need to find out, that also you put a question mark at the beginning itself. So later, so you can write the answer after completion of your the drawing. So with this, so we have completed the projection of points exercises also. So from tomorrow class, so I will start the projection of planes chapter we'll discuss. So today's class, any doubts or any clarification, you can post it here so that I can address to it.